Hello everyone. As the second part of today's notes, we're going to be looking at parallel and perpendicular lines, in particular the slope of these lines. Now before we get started, just a quick reminder that when looking at slopes, also known as m, our slope is equal to the rise of the function of the line over the run of the line. Or, put another way, the change in the y value divided by the change in the x value, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1, as covered previously on Mr. Rodriguez's video. I want to also draw your attention to some fundamentals that you might have learned previously in Algebra 1, but that we're reviewing presently. So, if two lines have the same slope, then we consider them to be parallel. Alternatively, if two lines are perpendicular, they're going to have a product of their slopes as -1. This also means they're going to have negative reciprocals. So for instance, here in number 1, find the slope of a line that is parallel and perpendicular to the given line. Number 1, we're given 2x plus 4. So to be parallel, they must have the same slope. So the slope here would be 2, because that is our slope here. Now to be perpendicular, the product of their slopes must equal -1, or to be negative reciprocals. So reciprocals, if you haven't heard that term in a while, it's where we take a number, make it a fraction, and then flip it, such that the numerator becomes the denominator. So the reciprocal of 2 would be 1 over 2. But 1 over 2 isn't good enough. We need to have the negative reciprocal, so we put a negative sign out front. All right, number 2. To be parallel, we must have the same slope. So our slope here is -2/3, so our parallel slope is going to be -2/3. To have our perpendicular slope, we need to have the negative reciprocal. We're going to take that -2/3, we're going to flip it to make it 3 over 2. And then we want the negative of a negative. Well, negative of a negative is a positive, so I'm just going to leave it as here, as this. So our perpendicular slope would be 3 over 2. All right. Number 3. Y equals x plus 3. Well, in this case, our slope in our original function is 1, because that x has an invisible 1 being multiplied by it. So our slope here for a parallel would be 1. And our reciprocal, well, we take 1, turn to a fraction, that's 1 over 1. We want the negative reciprocal, so that's going to be -1 over 1. -1 over 1 is the same as -1. All right. Example 2. Determine whether line AB and line CD are parallel, perpendicular, or neither for the following points, such that A is 1, 1, B is -1, -5, C is 3, 2, D is 6, 1. Graph each line to verify our answer. So the first thing we do, we check our slopes. So the slope of AB, that's going to be 1, 1, and -1, -5. So our M, our slope there, looks like 3. We check our CD. C is 3, 2, D is 6, 1. We plug them into our slope equations from the previous notes, and we get an M value of -1 over 3. So we analyze the relationship. If the slope of line AB is 3, and the slope of line CD is -1/3, we need to determine, are they parallel or perpendicular? Well, if they're parallel, then the slopes should be equal. But 3 does not equal -1/3, so these are not parallel. Are they perpendicular, though? To identify if they're perpendicular, we're going to take our two slopes, multiply them together, and we should get a -1. 3 times a negative 1/3 does equal negative 1. The product of the slopes is negative 1, so they are perpendicular. Last step, we graph it out. All right, now we do some guided practice. We want to determine whether AB and CD are parallel, perpendicular, or neither for the points of 0, 3, 2, -4, 2, 1, and 8, 4. Now, folks, I'm going to pause the video to work this all out. You should pause as well, work it on your own, and then hit play when you're ready to resume. And we're back. So, if we find the slope of AB using our rise over run formula, we end up with a slope of 1/2. By that same token, if we look at our CD, we look at our points, our rise over run formula, we get 3/6, which simplifies down to 1/2. These slopes are equal, which means that these lines are parallel. Now, unfortunately, my touchpad derped up a little bit over here, so these lines don't look exactly parallel, but that's the intent. If we had a straight edge to do this, it would be much better. All right, let's look at a few more. So, we want to graph the line that satisfies each condition. A slope of 4 that passes through 6, 2. So, slope 4 and a point. Now remember, folks, that that slope there, while written as a whole number, can also be written as a fraction. 4/1. Rise over run, it goes 4 units up for every point it goes over. It's going through point 6, 2. So let's find our 6, 2. 1, 2, 3, 4, 5, 6, and up 2. It's going to go up 4 units and over 1. Now that's going to put us off the screen, which is problematic. So instead we're going to work backwards. We're going to go down 4 units, 1, 2, 3, 4, and over 1 unit. For our next point. We're going to see if we can do that one more time. Go down 1, 2, 3, 4, and over 1. For that, connect our points. You get a fairly steep line there for number 2. Sorry, for number 1. Number 2, we'll do that in a slightly different color. Let's see, purple, let's go for orange. Passes through -2, 5, is parallel to LB, and LB has points 2, 1, and 7, 4. All right, so we want to pass through the point -2, 5. So -2, -1, -2, 1, 2, 3, 4, 5. And we want to have it parallel to LB. So parallel to LB means it's going to have the same slope as LB. So let's put down LB of 2, 1, and 7, 4. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So it's a little off our screen, but that's okay. We're going to connect that line there, hypothetically going out that way. And if we check our points here for LB, we're going to find that the LB slope is equal to 6/10, which is the same as 3/5. So we have our point here at -2, 5. We want to go over 3 units up 3 units over 5 units, but that's going to put us off screen in either direction. So we can't exactly graph that line on our coordinate grid, as the point after it is going to be off our grid, and the point below it is going to be off our grid. But if we had a big enough graph paper, as long as we had a slope of 3/5, we would be able to graph it out. All right, number 3. So we have a larger piece of graph paper now, so we should be able to work this one out fully. Passes through H at 8,5, is perpendicular to AG, such that A is -5,6, and G is -1,2. Remember, of course, that when we have perpendiculars, that means we're going to have negative reciprocal slopes. So let's go ahead and put those points down real quick. All right, so if we take a look at our slopes here, the slope of AG, if we plug in our values, we're going to find our slope here has a value of -1. So to have a perpendicular line going through this, the slopes must have a product of -1. How do you get a -1 through multiplication? You multiply it by +1, which means that the slope of whatever line is going to pass through point H must have a slope of 1. Now, I have point H out here. A slope of 1 means it goes up 1 over 1, up 1 over 1, up 1 over 1. So we can chart out our remaining points just going up 1 over 1, or reversing that, to essentially give us a nice, clean-cut, perpendicular line to this initial value. Now, folks, of course, my touchpad is jerking a little bit, so the line doesn't look perfectly straight for my AG, but if you graph this out yourself and use a straight edge, you should see that these two form a nice little right angle. And that, folks, is our notes for today. Tomorrow we will have an activity based on this information.